Do we live in a universe of many, and are parallel dimensions possibly part of our everyday reality? Scientists have now discovered the first evidence of a parallel universe, and this could further imply that our reality is very different from what we previously assumed. In a multiverse of possibilities, times and worlds can merge, and we may even create worlds ourselves with our decisions and thoughts. The possible existence of parallel worlds and times is as much a concern for science as it is for Hollywood. In Coherence, Nothing is Coincidental, a group of friends experiences strange events while a comet flies past Earth. The comet's influence opens the gates to perceptions of other realities, and the people gathered must come to terms with the fact that they also exist in other worlds and times. At the same time, they try to unravel the mystery and are horrified to discover that dimensional jumps are a normal part of their everyday lives, of which they are usually unaware. In the quantum world, this is exactly what happens. Experiments demonstrating these fascinating phenomena are familiar to almost everyone today. Schrödinger's cat and Wigner's friend are two thought experiments that seem absurd, yet they are based on real findings in quantum mechanics. Both experiments suggest that our decisions may carry us into countless parallel worlds and that reality is not as clearly defined as we think. Another highly acclaimed film, 2007's Parallel Worlds, Parallel Lives by Mark Everett, son of Hugh Everett III, the legendary quantum physicist, explores these ideas further. Hugh Everett III's many worlds interpretation proposed that all conceivable variations of your life exist in an alternate universe. For Everett, these findings were inevitable. His experiments and research in quantum mechanics in the 1950s led him to propose the many worlds interpretation in 1957. Everett's explanation of reality brought together famous paradoxes and ambiguities of quantum mechanics. His theory offered a radically different view of how seemingly crazy events at the quantum level could be interpreted. The many worlds interpretation assumes that all possible alternative histories and futures are real and exist simultaneously in a vast multiverse of worlds. Everett's concept stood in stark contrast to the Copenhagen interpretation of quantum systems, which assumes that while several possibilities exist in quantum space, only one variant becomes reality. According to the Copenhagen interpretation, we determine reality through our measurements, expectations, moods, feelings, and decisions. In contrast, the many worlds theory suggests that measurement by an observer doesn't occur in the classical sense. Instead, in every quantum mechanical interaction, every possible variant is realized in its own world. This means countless parallel worlds must exist within a multiverse. Imagine how this idea might look in everyday life. You wake up because your alarm clock goes off, and you must decide whether to sleep for another 5 minutes or get up immediately. In the world we know, this decision seems trivial, but in the many worlds theory, it creates two distinctly different universes. In Universe A, you get up immediately, which starts your day earlier and sets off a chain of events. Leaving the house earlier could help you avoid a traffic jam, arrive at work on time for an important meeting, and impress your boss with your ideas, positively influencing your career. In Universe B, you sleep for 5 more minutes, drive into a traffic jam, and arrive late for the meeting. Your competitor has already presented their idea, and your late arrival leaves your boss with a negative impression, potentially harming your career. This example illustrates how even a small decision could lead to vastly different life events. Everett's model and the Copenhagen interpretation differ significantly in how they view these outcomes. Everett believed you exist in both Universe A and Universe B simultaneously without realizing it. The Copenhagen interpretation, however, concludes that the reality you consciously experience becomes realized, while the others remain undefined potentials in quantum space. The question of whether each decision leads to another universe or whether branch-offs occur only at key moments remains unanswered. Another exciting question is where these parallel worlds exist and whether we can ever become aware of them. Parallel worlds are also tied to phenomena like the Mandela effect, which suggests that large groups of people may occasionally experience shifts in dimensions or parallel realities. An example is the widespread belief that Nelson Mandela died in prison in the 1980s, despite historical evidence proving otherwise. This phenomenon could indicate that we live in overlapping realities or experience perceptual anomalies shaped by parallel worlds. Perhaps, even now, you and I are living in parallel dimensions, navigating countless possibilities without knowing it. In fact, Mandela was released and even became the president of South Africa before his death in 2013. It's astonishing how thousands or even millions of people believe that Mandela was dead in their reality. The news of Mandela's death as a former president loomed like a specter. They wondered how it could be that Mandela had died when, in their memory, he had actually been dead since the 1980s. There are now hundreds of examples of the Mandela effect around the world, and they seem to be growing all the time. Other examples that might surprise you include the Star Wars character C-3PO, the location of New Zealand, and the Monopoly game. Millions of Star Wars fans remember the droid C-3PO as being completely golden. In fact, C-3PO has always had a silver leg, which surprised many fans when it was pointed out to them. The location of New Zealand is another fascinating example. Where would you say this island is located, south or north of Australia? Some people remember New Zealand as being northeast of Australia, when in fact, it is southeast. This geographical confusion is so widespread that it has even led to the assumption that New Zealand could be north of Australia in another reality. Then, there's the Monopoly figure. Many recall Uncle Pennybags wearing a monocle, yet he never had one. Nevertheless, millions of fans of the game are certain they remember seeing game boxes featuring a monocled figure in their childhood. Leaving behind perceptual phenomena and theoretical quantum experiments, we now turn to tangible evidence for the multiverse. While it seems incredible that every decision we make could catapult us into parallel worlds, astrophysics has long suggested that other universes can exist. Researchers have even found evidence in the cosmos. These other universes do not necessarily have to be parallel worlds. The multiverse could give rise to many different universes, each with unique conditions. For instance, universes created and existing one after another, or even side by side, are possible. Researchers have theorized that the Big Bang itself could have created multiple universes. British researcher Sir Roger Penrose presented a coherent paper suggesting that our universe is cyclical and originated from a precursor universe. Penrose based his work on the study of the cosmic microwave background, the oldest electromagnetic radiation that originated shortly after the Big Bang. It is considered a primordial matrix of the universe that remains observable today. Penrose and his team found concentric circles in this matrix, which could be interpreted as mathematical evidence of a previous universe. These circles might have originated from black holes in an earlier universe. Adding to this evidence, the James Webb Space Telescope recently discovered black holes so old they may have existed before the Big Bang. This could be the first visible proof supporting Penrose's theory. The possibility of multiple universes forming during the Big Bang was also deduced from specific patterns in the cosmic microwave background, which served as computational proof. Astrophysicist Laura Marcinitan, a renowned expert in theoretical physics and multiverse research, has published several papers providing evidence of other dimensions and universes within the cosmos. As a professor at the University of North Carolina at Chapel Hill, she argues that our universe cannot exist in isolation but is part of a much larger multiverse, an immeasurable collection of universes existing alongside, above, or within one another. These universes are not passive neighbors but interact with each other. Some dimensions and worlds might even exist within ours, influencing us in ways we do not perceive. Marcinitan has pointed to anomalies in the cosmic microwave background, such as the so-called dark flow, as evidence. Dark flow is a previously unexplained, coherent movement of galaxy clusters, interpreted as a possible signature of gravitational forces from other universes. She also proposed the selection principle in the multiverse, which suggests that our universe was specifically selected to produce life as we know it. Some theories even build on this idea, proposing that the cosmos was created especially for humans and that we may be co-creating protagonists in this grand narrative. While Marcinitan's theories are grounded in solid theoretical calculations and supported by interpretations of cosmological data, they remain speculative, much like other theories on parallel worlds. On the whole, measurable evidence for the existence of other universes continues to increase. It seems as though a new worldview is slowly emerging. Even in the voids, the largest empty spaces in the universe, researchers have recently found evidence of a collision between our universe and another. These cosmic scars could be the remnants of such an interaction. As scientific discoveries unfold, they bring us closer to unraveling the mysteries of the multiverse and its implications for our understanding of reality.